so I can put it up online for you to go back to in case I go too fast, because you know I do that. Okay, so it's recording. So water is a solvent. It's considered the universal solvent, and I'm gonna, like I said, let you read a lot of this. Why is this not wanting to advance? There we go. On your own. So these are little fact pieces here. The high latent heat of vaporization and things like this that possibly we talked about previously, and maybe we just don't remember because that's been months, a few months back. But what we need to focus on for this is the solution aspect. So we talked about hydrogen bonds. And here's something. Water's liquid at room temperature, which is unusual for a molecule with such a low molecular mass. Usually it's gases that have that low molecular weight, so not a liquid. Okay. And it's polar, and that allows it to be that universal solvent because it will other polar molecules will dissociate in it. Okay. I think I talked about that because I talked about sodium and chloride and how the sodium would kind of dissociate from the chloride in the water. Does that sound familiar? Kind of drew the beaker up on the board. I know it's been a lot of water coheses to itself. I think we talked about that. I don't know, maybe I'm getting you confused a little bit with my biology class because we cover some of this stuff in that class as well. But coheses, that's why it forms little beads on the surface of like wax, a waxed car, anything that isn't polar, because it, like wax in particular, is hydrophobic, doesn't like water. So it will repel the water and the water will cling to itself. It attracts to itself. Those hydrogen bonds attract to itself. And so that coheses. Adhesive means it will also adhere to some surfaces, obviously not wax, but other things. So it will adhere to glass. And that's why a little capillary tube, you can see the water drop in it. And I think I did talk to you about the straw, right? Remember the straw, how the water will go up the straw? Sound familiar?
Maybe,
No?
not
Maybe.
sure.
Okay. All right. Well, it's probably good we're going back over this then. So due to this hydrogen bonding that goes on, water can absorb a lot of heat before it will change temperature. And so that has to do with those bonds can vibrate and get really excited and move a lot before they actually break. And so think about how long it takes to boil water, how much energy you have to put into that water to bring it to that temperature. You know, if you've ever tried to boil water over a campfire, it burns a lot of wood. You know, if you're doing it in the kitchen on a gas stove, there's a lot of flame there. Electricity is not so visible, but you know, you've got to put it pretty high and leave it for 20 minutes, okay, to get it to boil. So it's a lot of energy. And so the amount of heat required to raise 1 gram of water 1 degree Celsius is called a calorie. Okay. And the same is true for losing heat. It holds onto that heat and loses it at a slow rate. So this helps cool our bodies. Okay, sweat absorbs the heat energy from the body in order to evaporate. In order to change form from liquid to gas, it has to pull all that energy out of our body to change phase. So that's why sweating works to cool us and get rid of body heat. Also, that's one of the things that regulates temperature on this planet, because 2/3 of the planet's covered in water, and it absorbs heat from the sun and then slowly radiates it out at night. And that's why our planet can maintain a relatively constant temperature. And I mean, well, of course, they're sitting here going, well, it's 60 degrees in the day and freezing at night the last 3 days. What do you mean constant temperature? I mean within a realm that we can live in. Okay. Other planets in our solar system don't have water. They don't have atmosphere really, but they have different atmosphere from us, but one that's usually lacking in water and things. But they don't have bodies of water to do this insulation. They're burning hot in the daytime when the sun is shining on that part of the planet, and then at night freezing cold. I mean, we're talking, you know, 0 degrees, uh, you know, many hundreds of degrees below zero. So yeah, this is a very important thing. This property of water, it's a very important thing for life, makes life as we know it possible. Frozen water is less dense too, so it traps air in it when it freezes, so it floats. And that's, again, something unusual. All other liquid molecules, when you freeze them, they're denser than their liquid form and they sink. If water were to sink, then ponds would freeze solid in the wintertime much more than they do. Right now, you have to be really, really cold part of the world and have a rather shallow pond for it to freeze solid. Here, um, we have to have a pretty shallow pond for it to freeze solid in the winter, especially with the winters we've been having recently. I remember some uh, winters when I was a kid where my dad, had a shallow pond or two, occasionally would freeze solid, and he had to bulldozer out dredging that pond out the next year, next summer. But because obviously it wasn't deep enough, but it's water. When it freezes floats, it actually produces an insulating effect and will prevent the water from below it getting as cold. So when ice thickens, that's because it's been cold for a really long period of time, staying really cold, and that insulating factor is not enough. But then the thicker the ice, the greater the insulating factor. So it really does prevent the water from freezing all the way through. If the ice sank and the top froze again, and then that sank, and then that sank, and just build up these layers of ice, then even deep lakes and oceans would freeze solid in places. That would prevent anything from living there. Fish, plants would not survive the winter. So again, those strange properties of water that don't fit the model for other molecules allow for life to happen. So solutions, there's going to be some solution questions on this test. Mostly they are just theory questions. Okay, actually they all are. I don't have any calculations of solutions. If I do, I mean like percent solutions or percent compositions. Where solutions have come in for you is molar solutions. Okay, I may ask you to calculate molar solutions and that stoichiometry step, but that's review, okay, from last time a little bit. What we're supposed to be getting to here briefly is acids and bases, okay, is what's coming up on this. But that's not going to be on this test, and I may do a very abbreviated talk about acids and bases and buffers and get us on into organic molecules, and that's going to be it. Call it good, okay? So the solvent is the water, usually, the liquid, typically, that things are being dissolved in. The solute's what's being dissolved. Solvent doesn't have to be a liquid. It can be something that is, believe it or not, it can be a solid. It's weird. You can dissolve a solid in a solid if you've got the two right solids. It could be a gas. Dissolve gases and gases. But usually, most commonly, we think of this as a liquid. And the solute can be anything, including another liquid. Usually it's a solid. We think of it as that, but it can be a solid or a gas. So whatever's being dissolved in the other thing, okay, is the solute. The thing doing the dissolving is the solvent. Okay. So a solution contains both of those. And here's three terms that are important. There will be questions about this on the test. Okay. Isotonic. Iso means equal. So this is a solution that is equal in solute concentration to that of the cell, and the cell neither gains nor loses water. And this is important because if you haven't had A&P yet, I know some people take A&P concurrent to this class, but a lot of people take it after this class. So you need to know these terms because your teacher will expect you to know these terms. Okay. And I'll probably present them again, but again, it's easier if you've already got it down because you've got a lot of other things to worry about in that class. Okay. So I'm going to use example blood cells because that's probably how it's going to be presented to you in that class to start with. Our blood is 0.9%. Something you might want to take a side note on. Let me see if I can. That's a decent color. So there's my point. That's my point. Okay, 0.9%. Saline, that means salt. Okay, we have that dissolved in our blood. So our blood cells are, the inside of our blood cells, the components of our blood cells are 0.9% saline. Okay. If you take a blood cell and you drop it into a 0.9% saline solution, the water will flow in and out of the cell equally. Okay.
I have a quick question, Ms. Rhoda.
Yes. Yes.
You say 0.9%, is that 0.09% or 0.9?
Oh, yeah, it's 0.09. It's what I wrote, not what I said.
Okay,
Did you see what I wrote up there? Yeah, 0.09%.
yes,
Yeah. Oh, I'm pretty sure. Could I
thank
be? Oh, I don't know. Now you got me questioning myself.
you. Okay,
0.9. Yes, I put it in the wrong place. It's right there. Thanks.
okay, uh-huh.
Okay, I'm gonna erase that right there, I think. There we go, 0.9%. Yes. Okay, so I said it right and wrote it wrong. I got, yeah, good thing you questioned me. Okay, 0.9% saline. So water will flow in and out equally. Okay, hypotonic. The hypotonic solution is where the water outside of the cell, okay, is more pure than what's inside the cell. So if you've got salt dissolved in water, it's not pure, right? But if you've got, say, distilled water, we'll go to an extreme example there. You've got distilled water, there is nothing dissolved in it. It's pure water. There's no salt, nothing. Water out of your tap, it's got stuff in it. It's got other things in it. Maybe, you know, different types of salts and things, not just salt, but like table salt. But it's not pure. Now it may be, and it will actually be hypotonic to your cells. Okay, but it's not totally pure because there's stuff dissolved in it. So I'm using the extreme example of distilled. So we have nothing dissolved in that water. If you take red blood cells and drop them into distilled water, and you will probably get to do this in micro class if you haven't had micro yet. When you take micro, if you're taking in the summer, this is something you'll probably get to do because she used to have you do it, and I used to have people do it when I taught the class, is you prick your finger and put some of your own blood onto a microscope slide, and then you you actually, if you do it right, you can use one blood sample, okay? Uh, and so you don't put it in the hypotonic first, you put it in the hypertonic. But anyway, what will happen in a hypotonic solution is that the water will flow into your blood cells. And since your blood cells do not have a cell wall or anything around them, they will expand and expand and expand, trying to equal out that salt concentration on both sides. Okay, and it can't because you can never make what's inside the blood cell pure. Understand that? So it will keep gaining water until it bursts like a water balloon. And so you can watch your little blood cells under the microscope on that slide just pop, 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 pop all over. All right. So that's hypotonic. That's where the water will flow into the cell. And something we're not really worried about here in, you know, look at studying animal and human science, medical type stuff is plants, but plant cells do have a cell wall, and they don't burst. Okay, that wall, it's like putting a water balloon in a box and trying to pump water into the water balloon. It'll fill up the space that it can, and then that box, the outside of the box will start pushing the water back out at you as you're trying to pump it in. So that's,
I have a question about the microbiology.
yeah.
Do you recommend taking microbiology before or after A&P?
Wow. I don't know. Most students, I think I know, if they don't take micro in the summer, they take them simultaneously.
Okay.
My recommendation
Mhm.
is, if at all possible, take micro in the summer by itself. Okay.
Okay.
Where you can focus on just it. It's 4 days a week. It's lab twice a week, but there's a lot of memorization in that class. It's about memorizing bacterial families and the diseases they cause. and to some extent the symptoms of those diseases. Okay. And you will also talk about viruses, and you'll also talk about your little animal parasites, your single-celled and the protozoa, and then your multicellular animal parasites.
Okay, my plan was to take it in the next spring by itself. Would you recommend that instead?
Is like the only class you're taking instead of, or just the only science class you're taking?
No, it'd be the only class I was taking.
Yeah, I think it's good to take it by itself because there is a lot of memorization. And the students that
Okay.
the students that I have taught that have been, and of course A&P has tons too. You've got to memorize all of your bones, and you got to memorize all of your cell types and tissue types and organ types and organ functions and the tissues of the organs. That's much organ types is which organs are all in the same organ system, but then each of them have different tissues inside of them, and that make them up. And I have never taught that class, and that is A&P is honestly my weak point because I'm a plant geneticist and not a human animal study scientist. So I fall down a little bit on that, but like plant physiology was like same stuff. You had to learn all the systems of the plants, the different tissue types, and the yeah. So it's a lot of
Okay.
memorization in both classes. I don't think taking them at the same time is a good idea at all. No. As far as which one to take first, I don't know that matters as much.
Okay.
Okay.
Thanks.
Sure. Okay, so hypertonic is a solution that has more salt dissolved in it than 0.9%. So if you were to take that same scenario and looking at blood under a microscope, and you put a hypertonic drop saltwater droplets onto your slide, you're going to see all the water rush out of the cell, and it's going to cause the cell to all shrivel up, and it's called crenulate. And that's really cool. And the cool thing on that one is then you can turn around and you can drop an isotonic solution on it, and you can watch them all fill back up until they're nice and happy. So in the lab, that's usually what you do is you stick a hypertonic solution on it first, and then you bring it back with an isotonic solution, and then you put it in the hypotonic and burst them all. That way you get to see all three stages with only pricking your finger once. But those are 3 solutions, and of course those solutions can occur in many. You can have hypertonic, hypotonic, and other types of situations other than blood cells. If you're passing anything across a membrane of any type, intestinal membranes, blood barrier membrane, of course, that's got a little different thing. But anytime you're going to cross any type of cell membrane or membrane of even man-made membrane, these properties are going to apply. Okay, so this will also apply to dialysis. All right. When you wind up talking about that. Okay, let me see if I can get this to advance. It's not going to advance again. I'm going to go ahead and erase. I don't think that's why it's not letting me advance. Well, I may have to. Oh, great. It's like my computer's frozen.
I can still hear you and see you.
Great. I'm glad of that. My presentation mode is not wanting to work for me though. Okay, what are you seeing now? Can you see 2 slides?
Yes, I can.
Yeah, you can see this slide and the next slide. Well, just ignore that. Okay, ignore that second slide. This is what my computer's been wanting to do all morning, and I've been trying to get it towards only showing the slide I'm talking about. So when we talk about water attracting to things, if it's hydrophilic, other things that are hydrophilic like water. Philic means to love or a lover. Hydro is water, so water loving, hydrophilic. Phobic, phobia, you have a fear of it, so hydrophobic. Hydrophobia is fear of water. So molecules that are hydrophobic are afraid of water, won't interact with it. We're not going to worry about that. No fluids. Okay. So concentration of solution. We can do by volume and by weight. Normally I have you do calculations of these. We're just going to skip that. Salinity, yeah, we'll skip that. But molarity, we've already encountered. And so remember that, don't lose molarity. Okay, that's your moles of solute per liter of solution. Okay. Again, we'll skip this concentration stuff because we lost a couple of weeks, you know, and we also, I think, having to learn on your own so much this way, it's a slower process. So I think we just need to try to cover less and get, you know, what's I don't know, really important thoroughly, I guess. Okay, so but temperature and pressure. Back to our gas laws and things, temperature and pressure have effects on the solubility of gases in a liquid. And so that is, you know, what your Charles law. Of course, gas is in a liquid, that's Henry's law. Okay, so just keep that in mind. In general, gas solubility decreases with temperature and increases with pressure. And so again, this is why pop, okay, if you know we bottle it under pressure with carbon dioxide pumped into it, and at pressure that gas goes into solution. It when you release the pressure by opening the container, then it rushes out, it fizzes, okay, and you get bubbly in your drink. And also you pour that over ice and get that cold, and it's going to help it come out faster. Okay. All right. So electrolytes, these are things in our body, in our cells, that conduct electricity. And they don't have to be in our body. Whoa, back. You know, we can have solutions out in a beaker that conduct electricity. And a non-electrolyte is something that doesn't conduct electricity. And again, typically I'll have a whole worksheet of things that are electrolytes and not electrolytes that I will have you distinguish, but we'll just go with the definitions. So there might be a definition question on the test, and that'll be it on this. Okay, electrolytes conduct electricity, non-electrolytes don't. Very basic, very simple there. Okay, boiling point of a substance is when the pressure of vapor escaping the liquid is equal to the atmospheric pressure on the liquid. Freezing points, that's where the phase change occurs. That was last test. We talked about that a bit. pH. Okay, so I'm supposed to have acids, a little bit of acids and bases on this test. And so here's probably about all that we'll mention. Acids will release hydrogen in water. Okay, it means you've got hydrogen floating around that can bond to something else. So things that donate a hydrogen in the formation of another compound, okay, possibly would be considered an acid. Okay, that's why if you mix an acid and a base together, remember my hydrochloric acid and sodium hydroxide, hydrochloric acid and lye. I think I always call it my Batman scenario. Does that sound familiar with that? The Batman, and I have the Riddler, and the Riddler's thing is if you can mix this solution, neutralize it, you know, you'll get out of the trap. Okay, for the old 1960s campy show. The hydrochloric acid donates that hydrogen ion to the hydroxide, the OH in that sodium hydroxide to make water. Okay, so that it's donating the hydrogen, so it's an acid. The base, okay, on the opposite, it is defined as either a hydrogen acceptor or a hydroxide donor. Okay, there's kind of two definitions of acids there. There's a Arrhenius acid and a Bronsted-Lowry acid, and the two definitions, one's more restrictive than the other. Okay, because you can see that there are things that might accept a hydrogen that aren't necessarily composed of hydroxide. All right, so yeah, one of those. Anyway, don't think I have that information on these slides. That's usually in a worksheet, so we won't have to worry about that. Just look at look for basic acid and base questions. So how can we determine an acid? It's going to have a sour taste. If you want to taste it, you know, those old alchemy guys, they did things like that. Some of them died. You know, I've told you about that. So that's not a good thing. But lemon juice is an acid, vinegar is an acid, and we know they taste sour. Litmus paper, from blue to red. This is a lab I would have had you do probably last week if we'd still been in school. I would have actually sent you home with little cylinders of blue and red litmus paper to test certain things around your house, like lemon juice and vinegar and things along those lines. I would have had a few of those things available in lab too in case you didn't have any handy in your house, but that would have been part of the lab that you would have done. An acid is going to react with active metals to release hydrogen gas, and it's going to neutralize bases to form water and salt. Okay, different types of salts. Okay, the base is kind of the opposite. It's either going to take up a hydrogen or it's going to release a hydroxide. That talks about both types of scenarios that can happen there. Tastes bitter as opposed to sour. And that's a slight distinction sometimes, but think about it. It's going to feel slippery. So soap, if you've ever eaten soap, you know, had your mouth washed out as a kid because you said something you shouldn't have, that's a base. Okay, it tastes bitter and it feels slippery. It's going to do the opposite. With the red litmus, it'll turn it blue. And then, of course, it neutralizes an acid. It's the other half of the neutralization equation, and you're still going to wind up with water and salts. pH scale. There we are. The range goes from 0 to 14. It's a logarithmic thing. We're not going to get into the math of calculating that. Anywhere you work, if you work in a lab, you're going to have a pH meter. It's just going to give you a reading. So acidic is -7. I mean, sorry, -7. Less than 7. Basic is greater than 7. Neutral is exactly 7. And to be very, very, very technical, that's 7.00000000 into infinity. And if out there somewhere before the end of infinity doesn't end, but somewhere out there you stick a 1 on the end of that, then it is no longer neutral. It is a base. Okay. That's technical. Okay, also 6.999999999 into infinity never rounds to 7 as far as this goes. That would actually be technically an acid. It's got to be 7 exactly. But in reality, we have a neutral range. A range, I think it's about like 6.7 to 7.1 or 2.
I'm sorry, the less acidic it is, the lower it'll be on the pH scale, or the
Yes,
opposite?
the lower the number. Yeah, so 0 is totally acid, and 7's at halfway in between.
Okay.
So yes, so yeah, 7.00, that one that's at the end, that's going to be a base. Sorry, I think did I say that backwards? Okay, sorry if I did. The thing is that our cells can survive within a fluctuation, and a narrow fluctuation of the pH, but that does allow some. In fact, I think I've read, and there's some information. I've seen some different numbers thrown around that the cell may actually be a little bit better at a slightly acidic pH, okay, than actually neutral. But I don't know how well supported some of those articles are. Okay, all right. So here is the scale with some common things you may have seen or know about, and where solutions of them would fall out onto the pH scale. So here you have 7. Everything from 7 to 14 is increasing in its base, where we have our sodium hydroxide, which is very strong base. Oven cleaner. These are both into serious levels of base that can hurt you. Okay. Whereas I've talked about a base burn can be as bad as an acid burn, maybe worse, because it doesn't. For me, the base burns I've had in chemistry labs didn't hurt. Okay, until they were already pretty advanced. Okay, through my skin. Whereas the acid burn, it hurt immediately. So I knew to wash it off and neutralize it very quickly. The base burn kind of snuck up on me. So I think it's part of it because it's slippery. A buffer is a chemical or combination of chemicals that keeps that pH within normal limits. And here again, normally I'd have a little worksheet that I'd hand you out, and you'd be we'd do buffers, and now what you have had is this week you did the buffer lab, right? Have you done the buffer lab yet?
Yes, and it
Yeah.
have, and it was extremely difficult.
I'm sorry. Say that
The
again.
the questions were extremely difficult.
Yeah.
Yes.
Yeah,
I-
they were.
I can imagine that is. It's usually a pretty difficult concept to understand in class, and the calculations on it are not easy. So we wind up spending usually a little more time on it in class to get the calculations down than I want to, or than we have time for. So again, other than a definition, I'm not going to have calculations on the test. Okay. Did you get the idea out of the lab though about the, how that buffer does absorb, okay, the changes in a solution so that it doesn't raise or lower the pH that much?
Yeah.
Okay. It is kind of
Yes.
an important concept that you at least understand a little bit about what's going on there, so you understand why antacids work. Okay. And there's some other buffer things that you'll encounter as you go through nursing school that it's important that you understand kind of what they do and how they do. So if it ever comes down to is that do we have to include a buffer in that? You'll know why. Okay. That's probably the most important feature on that, is the understanding of where it works, how it works, and that it is important, and specifically in some certain circumstances that things that are buffered. Okay.
I have a question
Yeah, go ahead.
about in the labs. So you have this know it for sure, not sure, and don't know it at all, or whatever.
Yeah.
How does that affect the progress of the lab? Because how does that affect? Does it affect the grade? Does it affect how long it's going to drag out?
I think it might affect how long it drags out. I'm not sure, because I haven't spent a lot of time doing those labs actually. What
would challenge
what happens is if you don't get the right
or
answer.
Mhm.
Okay, yeah, you're cutting out on me, so I'm sorry. What happens is if you don't get the right answer, it's going to ask you that question again, slightly different. It's going to change it, and it's going to come back around. I may go ask you 2 or 3 other questions in the meantime before it comes back around, but it will keep asking you those questions over and over and over again, basically until you get a certain percentage of them right. And you can get out of those quizzes without having a perfect score, I know. So I'm not really sure what it's what kind of logarithm they've got in there that says, okay, that's enough, we'll let them go with this grade. But I do know that it will cycle back around with questions you've missed. Okay, because one of the frustrating things for me as a teacher is I'd like to be able to go through that lab and just be able to see what it's having you do and see the questions it's asking you. And I don't want to take the time to sit there and try to answer them, and I definitely don't want to have to sit there and do calculations and all of that sort of thing. I just want to go through the lab and see what it's having you do and how it's making you do it, and that sort of thing. And I can't. And it'll sit there and make me take the quizzes too, and I can't progress until I go through the quizzes. And I'm like, I just put an answer, and I, because I don't have to stop and do calculations, and it won't let me out. So, yeah, and I don't know, I've played around with it a little bit where I put I'm sure, I don't know, or whatever, and I don't think it makes any difference from what I can tell. It just keeps making you answer until you.
I don't know. It took me, I think, well over 3 hours to do it.
Yes, these labs are long. Especially if you want a good grade.
Yeah.
They're supposed to be like an hour and a half, and of course we've got a 2-hour time slot for it. But my biology students also, and that's one of the things. That's one of the arguments I've kind of made for. They told me that I couldn't do these where the class didn't meet, when we were having regular. That doesn't apply now, of course, but back during the semester, they said if I was going to do online lab like that, I had to book the computer room over in the lab building and have it all day because I have 3 labs all day, back to back all day. I had to have that room available for my students to come in and me be there to help them, so they could do the lab there in case they didn't have good internet and that sort of thing at home. And I'm like, well, I understand that, but these labs oftentimes take more than 2 hours. So, sometimes it doesn't, sometimes it does. You never can tell. If you run into problems with something unexpected, it's like, I don't get this, and you got to keep going back over it again. It'll take longer. And so that's my argument of why people should be able to do it on their own time. They did fix the glitch where you could go back, you can stop, and you can go back and pick up where you left off. Okay, that used to not allow that.
How do you do that?
How do you do that? I think you just log out. Okay. And that may be a glitch they didn't fix in the chemistry ones, but you've done all the chemistry ones so far. So the biology ones, I know that there is like an exit button, I believe, on the left hand bottom part of the screen where you can leave the lab and
Okay.
and you can come back in. And I think it does an automatic save too. But anyway, we tested it out at the beginning of the semester because that was something I had been told through an email was fixed, but I wanted to make sure because that's been a big problem for students, not being able to come back in and having to do it all in one sitting. And so several students went in and did it, and I played around with it, and it would let us come back in. So from here on out, for sure, you should be able to do that on all your labs,
Okay.
all the biology labs. Okay.
Okay.
So let's see. I think that should pretty much prep you for the test. Like I said, most of it is your gas laws. There's just a few questions about some of the stuff I went over here, and it's more basic definition type questions. Okay. That if any that are on there, they're going to be that type of arrangement. You will have an hour and a half to take the test. It's 50 questions, multiple choice, but you will have to work equations out. Okay. Your gas law equations out, but your answer options should be there.
What's the ratio of the, like, how many equation problems are there? Do you have any idea?
Most of the test. Okay.
Most of
Well, let me see.
equation problems?
Yeah. Gas laws. Okay, so the first page is all, well, of course, this is my test from last semester, and I may modify it just a hair, but probably not much. So the first 2 questions are pretty much more about definitions and naming, okay, what law does this and what law does that for us. And starting on page 3 with question 19, I'm asking you to make calculations. And of course, there's possibly a little bit of molarity stuff still in there, review of the molarities. But yeah, the rest of the test is pretty much calculations.
Okay.
But unlike on a regular test, if I were giving you this on Thursday during lab time, like I intended, I would not let you have your gas law sheet out. All you would have is your polyatomic ion cheat sheet, okay, for figuring moles, and a periodic table. But here you can have your equation, your formulae there in front of you. In a normal semester, I would make you have those memorized, okay? So here you don't. You can have that sheet to refer to and go, okay, this law I do this, and this law I do that. And I think that may help, I don't know, speed you up a little bit on things. At least take out some of the doubt, okay? But I expect you to have that there, okay? So questions, if I change wording or anything on them like that, it's going to be, I'm going to assume that you've got that information, okay?
Okay.
Somebody asked a question about the answers to Dalton's law, and it's there. Those answers, if you scroll on to like the last page, there's like, I don't know, 3 pages of questions or something, but all the answers should be up. You just need to scroll to the end, and they're there. They're in red, I think, on that one. And then the others, I worked them out and took pictures on my phone and put them up for you to see how they were worked out. The Dalton's Law, I didn't work them out for you. Those were the answers. They came with that worksheet, and I just took it, put it up there. The others didn't have answers, so I had to go work those for you. Did everybody find all that okay?
Yes.
Okay. How was the quiz?
I did average. I got 8 out of 10.
Average 8 out of 10, yeah. So that's kind of it. I mean, I gave you, I think pretty much one of every gas law question. So that's what the questions on the test will be like. Different scenarios, but it's all going to be the same formulae, and you're going to be given pressure, volume, temperature, and one of them you won't have, and before and afters, one of them you won't have, and you're going to be asked to do the calculations. Yep. So it's just basically plugging in your numbers to your formulae.
Bugs were on them. I was outside. Bugs were on them. I ate them on my Zoom conference, and I went inside and bugs.
I'm going to mute him real quick. That's what it's just more of that. Okay, so hopefully that makes you feel a little bit better too. Look at your formula, write down what you have, see what's missing. That's your X, and you're going to solve for X. Be sure and well, rounding with multiple choice. If your answer is slightly different from all the choices given because your decimal points are different, then round to the closest. Okay, look what's the closest option, and that's I'm not going to get into sig figs. I'm not going to count you wrong if you have the wrong sig fig. In fact, I believe on my answers I've written them out to where sig figs is not even an issue. Okay, it's not like, well, it should be this one or that one because you get a certain number of sig figs. That's not how I design my answers. Okay, I want you to just calculate it right. Okay, show me you can work the equation properly. Okay, and we won't focus on sig figs. Okay, what other questions do you have of me? Let me put Gerald back on unmute here. If I mute you, you can always unmute yourself by pushing the space bar. Okay, all right.
I don't have any questions about the quiz or anything. I do have some questions I need to ask you about my grade and stuff though later if you have time.
Okay, sure. Yeah. Grades, I'm starting to get them up onto D2L. They had no way that they could figure out how to import. It's supposed to be able to be done, but couldn't figure out how to import out of Excel into D2L. So I'm having to type everybody's in individually, and I'm getting them in there, but it's taking me some time. So what you're seeing in D2L is not going to have a total percent. But if you look at it and you take your score and you total up all the total possible points, you can take your score, divide by your possible points, and that's going to be that decimal will be a percent, your percent grade. I don't have any labs in there right now either. I'm trying to get that updated this week. Okay. Oh, and Melanie, I found a paper of yours that I was missing. I think maybe you handed it in late, but yeah, the atomic molecule lab where we counted the protons, neutrons, electrons on the atom models, and then we did the flame tests.
Yeah.
Yeah. I think I was missing that for you. Seems like we had that conversation. Yeah, really. So do what?
I didn't even know that you were missing it.
Yeah.
You never
I'm not sure when I realized it may have been over spring break when I realized I was missing that for you. I don't know, but yeah, I didn't have a grade for you on it. but you got a perfect score on it. Okay. I'll get that into D2L here when I can. But if you,
Okay.
I'm not sure if I don't know if I have those grades in D2L anyway, but if I do and you look and you see it's missing, well, I found it. I was going through, well, I pulled like everything that needed to be graded out of my drawer and just threw it in a sack on the Friday before spring break and brought it home because I was pretty sure this was going to happen. So I was trying to get everything that was undone home with me so I could do it. So I was going through papers and it's like this one lone paper popped up and I'm like, oh, okay.
Okay. And so the grade from our last test, so all those different grades, they will be posted under grades as well?
Yes. Do I have anything for you under D2L yet? I may not. I've been swamped trying to get the biologies
Today.
and
I have not looked today.
well, and I haven't done anything in this week. So if it's not if nothing is showing, then I don't have anything in there for you. So I will work toward that. Gotta get this test in there for you first. Okay. But then I graded all day yesterday on stuff and I'm graded some this morning and I'll be grading again this afternoon after I get the test loaded up for you. Okay.
Okay. Can you put the PowerPoint on D2L somehow?
The one I just went over here today? Yes, I will. Oh, I probably should go ahead and stop this recording. If it'll let me. It's not giving me my little options. There we go. Okay. Yeah, I will. It'll take a little bit of time. There'll be a lag because this has to, it's got to convert and then I've got to put it up on YouTube and then it's got to convert and I got to get closed captioning on there.